So if you see my screen, you see a picture there of a switch panel. So Joel sent me this. Joel has a little truck here that he wants to put an aftermarket switch panel. Looks like there's some sockets and a little gauge. Put something like that on the dashboard of this little truck so you can control lights and have things plug in, which is an excellent sheet metal project. So I thought we would go through Fusion, and I'll kind of roughly draw it out, just kind of, just kind of how I would do it to show some different features from the Fusion sheet metal part of it. It's sheet metal module. And, it's not going to be exact to size or to scale or anything. Joel, that's going to be something for you to do at a later date. But this should at least give you the idea and the steps that I would take to do it. It was interesting. I got some good feedback from Chris on the 3D printed one. He wrote a pretty long comment on the Facebook group that he had a lot of good points. Especially how there's many different ways to do things in Fusion. Kind of many ways to skin a cat. And he had some suggestions on some different ways, and even some I think were improvements. And he even taught me a few things that I didn't know about Fusion. Which I'll mention as we go through this, because one of them was grouping features on the timeline. So he had a lot of good insight, and it sounds like he's done a lot of 3D printing of parts. So if you didn't see that chat, I recommend going to look at it. So let's bring up Fusion. Here's Fusion. So we're gonna start kind of as we start all things, with a sketch, a 2D sketch. We could either make this 2D sketch right here under the solid tool ribbon, or we can click on the sheet metal part here. And again, we still have the same things, the sketch. It's a little deceiving because a lot of things you typically go from left to right, right? If we're back in the solid, the thing farthest on the left is our sketch, and then we extrude it or revolve it, and then we can modify it and then do things like that. On the sheet metal one, why I say it's a little bit out of order is there's a one to make a new component. This might be like, let's say you have a larger assembly that has some solid parts already and you want to add a sheet metal part to it. This adding a new component would be the same as right-clicking and doing new component. In fact, you can see the little icon is the same. But you don't have to, especially like this, since it's only a one component part, we don't have to create a component for it. But the other thing to point out is that under the Modify tab here, there's the sheet metal rules. And this is where we define like the thickness of the sheet metal we're going to use. So if you click that, you get a little sheet metal rules window that pops up. And there are some default things: steel, stainless, aluminum are defaulted. And then I added this one, this aluminum 80 thousandths, about 2 millimeters. This is one that I use relatively frequently. It's a good size. It's thick enough that it's stable, it's structurally stable. You can bend it and drill through it. I can weld to it. It's not too thin to weld, but it's not super heavy. So this is a size that I use a lot. And so to create a new size, if you click on one of the materials, there's a little thing with a plus next to it, and it's like a little sheet with a plus in the corner, and that's the new rule. And so you can click that and you can define like the name of your rule and the thickness that you're going to use, the K factor, which is I think it's like the bending factor for it. I don't know that much about sheet metal and sheet metal forming, so I just stick with the default values here. But if you had a specific material, you could certainly Google it and figure out if you needed to put other values in here. There's also things for different bend conditions, the radii for different parts. And again, I leave this all as the default settings, but you can go and you can change this if you need, or if you find that if you're bending a specific type of metal and it's not coming out dimensionally as you expected, that's where you would do that. And then if you already have one created, the little pen icon, the pencil icon, is just to edit it. Brings up essentially the same window here. So you want to plan and have your sheet metal that you're going to use, the thickness or the material, defined before you start making your item. So we're going to start with a sketch.
Hey Van, are those sheet metal things? Can those be downloaded from McMaster-Carr?
I don't know. So McMaster probably doesn't really have that much sheet metal, but they might have some information about bending and stuff. They might.
Okay.
You wouldn't download it the same way that you would download like a screw or a solid model of a component, but they might have some values to put in for that. So yeah, so starting to draw out our thing again, sketching. We can choose one of the planes on the origin, and I'll choose this back one here. And now we can start drawing. We're going to start. I'm going to start with kind of that front gauge panel. You know, the front part. And one thing that I'm going to do is I'm going to make sure that my center point, my origin point, is at least centered left and right. And the reason I'm going to do that for this is I'm kind of envisioning this flat piece of metal with holes in it, and then kind of two returns on either side that are going to be mirror images of each other. And so if I make the origin in the center of that front panel, after I've created one of the sides of my part, I can mirror it over that center plane, and it'll be easy to mirror to the other side. So I'm going to specifically make a point to make this, and let's see, 150, that's about 6 inches. Yeah, we'll make it a little bit bigger, maybe 180. Make this height, make it 80. So there's a few ways I could define this to be in the center, right? I could either dimension off of the origin point to the edge, like this. And I could actually say that this is going to be this dimension, D1 over 2. And that puts it that way. And we could do the same for going to here. We could make this one this dimension over 2. And so that constrains it and puts our origin in the center. I could stop here and start making the solid with it, or I could draw in some extra geometries for some of our features, right? Maybe we have a hole here for a round gauge. Let me drag that down a little bit. Maybe we have some smaller holes for the accessory sockets. 25. Another one that's 25. Maybe some rectangles for those switch openings. I'll make this one, make that 25 as well. Put it up a little bit. Up to there. We'll make 3 of those, and I'm going to do that by making a pattern. So we'll select our lines here. There's 3 selected for my quantity, and then I can do the spacing. I should actually make it 4. Go up into pattern 1, bring it to there. Okay. I'm going to just draw a horizontal construction line here so that I can snap this circle to the same line, just so it's lined up. All right. So I'm not going to bother dimensioning all of these things for right now. They can kind of float around as needed, but this will give us enough to just kind of make our front panel. And we don't have, well, there is an extrude feature, but to create a sheet metal part, you're going to start with this flange feature here, this the next button over. And the flange feature, the first flange you create like this will be from a flat sketch. So I can choose my sketch that I want, and I can set that the rule that it's going to be. So, right now, the thickness is going to be one side, and the one that defaulted was the steel. I'm going to choose my aluminum 80 thousandths. And when I click OK, it is now the right thickness for that. So I've officially entered kind of the sheet metal space because I've used the flange feature and I've defined one of the sheet metals that I had a rule for. Now, as we create more parts of this or more features from the sheet metal, we're going to use this flange tool. And if we click on an edge, we're going to pop up with an arrow, kind of like an extrude arrow. And we can now drag it out or type in a dimension that we want and start making a sheet metal piece with a little bend here. And we also have a degree changer. So you can see that as I sweep it through the different degrees here for a sharper bend or a less sharp bend, you can see that it is the radius here gets larger, as the material deforms. And so basically what it's doing is it's keeping, if you had like kind of a theoretical line where these two planes or surfaces met, it's keeping that line in the same location, right? So as you fold it over more, it has to make this radius bigger for the fold. And so that imaginary line would be off here a little bit, where if you had a very shallow fold, that imaginary line would be there. But for this, I think we can go with 90 degrees. There we go. And the distance right now, we have 75. We'll go a little deeper. We'll go to 90. And we have a few options here in our flange window, right? So we've got the height of the flange. That's really the distance from the base plane. We've got the angle that it's going to be. And then here's that the height datum. This again is on the outer faces. There's a little diagram that shows where they are going to go to touch based on the geometry. And there's different choices. You can choose an interface, which then would make it a little bit longer. So when I do the outer face, this 90 degrees is measuring from this planar surface that I started from to the back of the bend here. If I choose like interface, you can see it got just a little bit longer because now it's going to be measuring from the inside, this back side of the sheet metal. And tangent to bend is going to go to the center line of the radius here. But typically, I find that I use the outer face one. And then you have bend position. You have a choice of inside or outside. So that's like from that original size of the material, right? 180 millimeters across. Are we making it so that the flat surface of this return to the other side is the 180, or is it doing it from the inside? So outside means that the inner wall of this return here, so this surface to the edge here would be that 180 millimeters. And we can do outside. That's fine for now. We'll actually be playing with that and doing a few different ones. So here we have our kind of side for the bracket here. So I can hit OK. Oh, and there's a flip for flipping direction if you want to go and fold it in the other direction. So I can do OK, and then now we have our flange. Now let's modify this flange a little bit. Let's do two things to modify it, which I'm going to break into two different sketches just because I want to show you a way that we can, a little feature that we can do to for the bottom one. So we're going to create a sketch, and we're going to create a sketch on the surface. And really what I want to do is just kind of draw a diagonal line and kind of lop a triangle off the corner so it kind of tapers back towards the windshield. I'm going to start this by using a projection, making a projection, which is under our Create tool. There's Project, which is also the letter P. So the shortcut is just to press P. And I'm going to choose this whole face. And so it's going to take this face and all the edges associated with it and project it onto my sketching plane. And so I now have the purple line in the corners for it. I can now draw a diagonal line and now have a line here. Let's define this as at an angle, maybe, what does 25 degrees like? Yeah, maybe a little steeper, maybe 35. A little too steep. Let's go with 30. Actually, 35 might be okay. We'll leave it at 35. Now, when I finish the sketch, so actually, I want to point out this is one of the things that that Chris had said in the thread from last week. Is on this sketch, there's a little red lock in the corner, and that means every geometry is fully constrained on that sketch. This sketch, the first sketch that I made, has the little pencil in the corner, and not everything was fully constrained. So I didn't know about that. So we have our triangle. I'm going to do an extrude, choose that triangle, and we are going to have it go the distance to this side of the metal. It knows that it's going through the object, so it's going to cut, and it's going to remove that little piece. So there we go. So we have kind of a tapered angle down on one side. Now, once we start creating our sheet metal, there's this next tool here. So after the flange tool, we have the create flat pattern. When we choose create flat pattern, it will ask us to select the face that we want stationary, or, you know, I usually use like the most prominent face or the largest face of my sheet metal object. And if I click it and choose OK, it's going to do a little thinking and some math, and it's going to go into the flat pattern mode. And what it's done here is it has unfolded our bent sheet metal, you know, with using our rules here to figure out the bend lines and the center line. And so if you were going to cut this out of metal, this is, you know, you're going to use this flat pattern. Once this flat pattern is created and we finish working with it, it goes back to the folded view, and you'll see the flat pattern here in our tree, right? So in our document settings, we have our aluminum, our rule, the aluminum we selected, and then the flat pattern. And again, if we click the little button, it'll go back to the flat pattern view. There's some things that you can do that can break the flat pattern creation, and I will demonstrate that in a few minutes as we put more features in. But the next thing I want to do is the dashboard that this is going to go on has actually a little bit of a curve to it. It's not just perfectly straight. So one thing, you know, we can create a sketch that has a curve on the bottom here and remove that material. But one of the questions might be, how do we create that? I haven't found a real easy way, but I have found a way. And so what we would do is we would go to create a sketch. Or before we go to create a sketch, I've cut a little piece of cardboard. Here's a little piece of cardboard that I cut with just a curve on it. Maybe it's an approximation of a dashboard curve, something like that. And I have scanned it in on my scanner, my printer scanner. And so here's a cardboard cutout. And I have drawn a little scale on here so I can know that this is exactly 50 millimeters. And why I've done this is Fusion does not let you import a PDF, but it will let you import like a JPEG or a PNG file. So using Adobe, I can open the PDF. I can save it as, actually I have already saved it, but I can save it as like a PNG file or a JPEG file. And then when I save it, it's now a file type that I can pull into Fusion. But you're going to see in just a minute that there's a little problem when you pull it in. So we're going to create a sketch on this surface. And in the sketch tools, in the upper right-hand corner, we have insert. And we can insert some like a DXF file or an SVG, which is another vector file. This is where we insert like a McMaster component, that sort of thing. A canvas is an image. So if I click on select canvas, I can browse to this, choose this scan, And the face, where I want it is, right here on the sketch plane. And so here it is. So it has brought in that image, that scan that I made. But of course, it's now really small, and it should be much larger. There's probably a scaling factor that I can just figure out or learn from my computer, but I don't know what that is. So the easy way is to just, make this little scaling note on there, the little measuring note, and match it. So I'm going to, for right now, just say okay. And now what I really need to do is I need to draw a box that has a dimension 50 millimeters so that I can match up the scale on this image. So I can go back here and I can edit it, and I can, using the, so I can move it around. If the square lets me move it around in 2 planes, the arrows will let me move it in just 1 plane. The little rotation thing will let me rotate it, and then these lines will let me scale it in one direction or the other, and this little one in the corner lets me scale it uniformly. So maybe it's going to be about like that. And again, this, we're just going to do it approximately, but that's about right? My 50 millimeters is about matching that box there. So let's go with it. And so let's move this down a little bit. And let's say that maybe it's going to be about like that. Okay, and so it's here. So it is now on the sketch surface here. I can't select it or anything. There's a feature here when you go to edit it. You can make it selectable. Selectable? I thought there was a selectables checkbox. Maybe not. I was playing with it earlier, and I thought there was one to select it. Maybe it's when you first import it in, you can choose to make it selectable. But we have it not selectable, and you can also change the opacity if you need to see through it or whatever. But this gives us a little bit of an arc here. So I'm going to, at the very least, project this line. I'm going to go to my projection tool. We'll project the whole face. And so now I have the corners that I want to work with here. Under the Create tool, there is there's this this spline tool right here, Fit Point Spline. The spline tool allows you to make kind of a complex curve where you click points in a row, and it tries to match, wherever you're clicking. So what we're going to do is I'm going to click here, start on the corner, go up a little bit, make a few points along here, and then get to the end. And then now that I'm done, I'm going to go click the little checkbox. And now I have drawn a curve that pretty closely matches my cardboard cutout, my template. But before I finish, I'm going to do one more thing, and that is I want to make like a little mounting tab that's going to fit on the dashboard, and I'm not going to be able to create a flange from a curved surface like this. So I'm going to create a little square cutout. Zoom in a little bit here. Just going to kind of go, draw it a little high for now. We'll make it 20. So what I'm trying to do, and I think I'm just going to scooch this around a little bit. What I'm trying to get to, and I don't know if this will let me do this, is can I make this tangent? No, it's not letting me select the fit point spline because it's got too many tangent points because it's an unusual curve. So we'll just leave it like this. But what I'm going to do is use my trim tool and cut out a little piece of this. Cut out that little speck. There's a little hanging speck there. All right. So now, if I finish the sketch, we have our scanned there still on our canvas. If we are done looking at our scanned canvas, you'll see here in the tree there's a canvases view, right? So this is the scan that we brought in. You can either hide just that, or you can hide the whole canvases. But now you can see that we have our sketch. And so I'm going to do an extrude. I'm going to select that part that we created. I'm going to do that same thing where I'm going to do to object and choose the backside. And it's going to be a cut. And so now we have that little curved cutout. So the next step is, let's create a little tab coming off of this little flat edge we created, a little tab with maybe a hole in it, so that we'll be able to screw this down to the dashboard once it's created. I'm going to go up to my flange tool, select that edge. Did I select the right edge? No. So if you look, I selected the inner edge, not the edge I wanted. I can just click the little X here to remove the selection and select the edge that I do want. And we're going to come this direction a little bit. Yeah, maybe 15. That looks good. So if you look here, it's done a few interesting things. So we have it set to right now that the bend position is outside, right? So it's going to match the edge with the outside of the part. I actually want this to be the inside, and so what this does is it's actually moved it up a little bit, so that if you have that dash sitting under this curve, this should be pretty close to touching it. You know, this is now going to be right at about where I had that edge that has now been removed. And you'll see that the sheet metal rules in Fusion create these two little cutouts, these two little notches, to give yourself some bend relief to make your tab, to make your object. Like, it realizes that if you want to bend this tab so that this surface, you know, lines up with the outer edge of the part here, you're going to have to cut some material back. So I can click OK, and so there's our little mounting tab that we're going to use to screw it down. If I want to put a hole in here now, I can create another sketch, and we'll create a circle right kind of in the middle. Just make it, I don't know, doesn't really matter. I'll finish that, and we're going to extrude that circle. And you know, another kind of quick and dirty way, instead of, you know, you can just choose that arrow and just pull downward some, right? And it will remove material. Notice it's a cut. We can round the corners here a little bit, maybe like that. And so now we have a little mounting tab. Now that we have our mounting tab, we have our return, we cut out the top, we cut out the bottom to an arc. This is where we can use the group feature in the timeline, right? So as our timeline is getting long, so this flange right here is the start of that. I can select all of these items that I've just been working on, and I can choose create a group. And what it does is it now has a little plus here on the timeline, and it's telling me that I've collapsed a part of it. So now as I go to create more features and more things, I have a shorter timeline at the bottom of the screen, but I can always click on the little plus to expand it as well. But what I want to do now that we have...
Hey, man.
Yes.
I'm sorry. I was interrupted here. How did you create the tab? Last I saw it had a cutout, and now you have you drew the tab on the bottom before you bent it.
This little tab here?
Yeah.
So the tab was created automatically bent by using the flange feature, the little flange feature right here. So to make a flange, you choose an edge, and it makes the folded piece on the edge as its flange, as its part.
I see. Okay, thank you.
Okay, so we're gonna make one, we're gonna do one more step first, and then we're gonna make another flange on this top edge. So I'll go slower when I do that, and you should hopefully be able to see it. But what I wanna do now is I had said at the beginning I was going to mirror this return feature on the other side of the part. So I can now go up to create and do a mirror, and the mirror window pops up, and it defaults to the type is faces, but really what we want to mirror are features. So we can choose bodies or components or features. We're going to choose features, and now we can select the features that we want to mirror. And so we know that we want this flange. We know that we're going to want that cutout that we did on the top. We know that we're going to want that bottom cutout. We're going to want the little tab flange. We're going to want the hole, and we're going to want the radiuses around there. We don't necessarily need the sketches. We don't need another copy of the sketches. And then we need to select a plane that we're going to mirror on. So we've got 6 objects selected to mirror. We're going to select this center plane, which again is halfway in our part. And then OK, and it's going to think a little bit, and then there you go. It has drawn the exact same features on the other side. And if I go to our flat pattern, so right now the flat pattern has a little exclamation point, and this just means that it has not been updated. If I go to update, if I go to the flat pattern, it will update and think, and then there we have it. There's our, that's how our sheet metal part is now coming along and starting to look. And when I do finish flat pattern, it folds the things back up, and we're now ready to continue. So I will hide this, or collapse that little part of the tree in that group, just to make a little bit of room. And we're going to create a flange on the top of this to kind of enclose the backside of the switches, hide all the wires. So again, using the flange feature here, the flange feature, I'm going to click it, and it's going to ask me to choose an edge of the part to start with. And I'm going to choose this top back edge. When I choose that edge, I now get a pull direction that starts making it. And if you see, Marty, like, it's already folded. It's already in its folded position. And I can change the angle of the fold by either typing in or dragging the little slider here. I can make it whatever I want. Now, if I recall, the angle we made that 30 degrees. Which plus 90 would be 120. 120 or 35? Maybe we made it 35. One way that we can go to check is, we click on like the front view, and we can, look straight on. And yes, certainly we were working at the same angle with that back part that we made, or the side part that we made. Now, if you look right now, there's this funny little thing where our flange, our new flange is below our side pieces. Again, this is where, like, this is currently set to an inside bend position. This we probably want on an outside bend position. So the outside bend position makes it so that the top part of this is level with our starting flange. And so as you can see, this kind of lines up those edges nicely. And it looks like my length is about right to go down and match kind of the bottom of the sides there. So we will go with that for our next flange. So we've got this flange in place. And then now let's, to give it a little bit of structural strength, let's create a little tab from this top flange that folds down. So maybe somewhere along here that goes downward on the inside, that we can drill a hole through or put a hole in it, so we can maybe use a pop rivet. So we can make our side returns connect to our top little roof member here. So we can then create another flange. And if I click the line that I want, which is this one right here, right, I can say that, let's say it's going to go down a little bit. And there's a few things I can do here, right? So right now it's creating this flange that's the full length of that edge. And let's make it 15 will be good. That's the same as we made this little tab here, but we don't want it to be the full length of that edge. Luckily, in our little flange menu option here window, we have a full edge choice. There's a drop down, and we can make it symmetrical. There's a few options, kind of like defining extrusions from your reference plane, where you want to go. We can do the two offset or the two-sided, and the two-sided, we now have two little white arrows in the corners. I can now drag these arrows or type in values, and I can kind of specify where, where I want this to be. So we'll make it, maybe about like that. And again, going to look at our inside-outside tools, right? So we're looking up underneath here. If I chose this to be an inside bend, it moves it further away. So there's actually an air gap between the two surfaces. If I let it, you see that there? If I let it be an outer face, I'm sorry, it was this one. If I let it be an outside, then it's right up against the surface there. So that looks like a good spot for it to be. So I'm going to choose OK and create that flange. And so there it is. So there's that flange. Now, I have learned from experience that I have now actually broken the flat pattern. So here's our part. If I go back to the flat pattern, the unfolded version, it's not unfolding. It's showing it just as it was. And if you look down here in the lower left, the flat pattern is red. It's unhappy, it's red. And why this is because I have made this little tab, the tab we just created, is so close to this back surface here, they actually share, they actually touch. And so Fusion calculated them as being one, I guess, cohesive piece of material or one object. So it can't unfold this because it thinks this tab is part of this face, but it also thinks this tab is part of this face. So because it doesn't know where that split is, it can't unfold it. And so that's why we're having the folding error. One thing we can do is if we go back, so I just showed you how we came in a little bit on this tab, right? We came in from the edges to make it smaller than the whole edge. Let's go back to when we created this roof feature, this feature here, and let's go edit it. And let's, instead of making this full edge, let's make this a 2 offset. And let's make these offsets, it can be quite small. So, instead of negative 0.5, we can make it negative like 0.01. And then we'll make this offset the same, negative 0.01. And now if I do OK, what this has created is a 1/100th of a millimeter gap, in theory, between these two objects. So hopefully they are not touching. And now if I go to the flat pattern, aha, it likes it. So now we have our flat pattern because it's now thinking that this tab is not touching the other piece. And so it's happy to unfold it and create the flat pattern for us. We'll leave the flat pattern and let's put some radii on the bottom of this, like we did on the other one. So we'll choose this corner and this corner. I don't know, I think last time we did like 6 or something, 6.5. We did that. And again, because we're working on one side of our part, we don't need to draw it again on the other side. We can use that mirror feature. We can use the mirror feature. We can select, it's now set to features because it remembers what I used last time. I think we can either click on the feature itself, though I do want, well, I didn't, let's try this. So I clicked on just the feature, not on the parts in the tree. So if I do mirror plane, and it's going to be this plane. Okay, it kept the radii as it mirrored it, so it kept it in its most latest state. So there's our, oh no, it did not. Okay, so look at that. So it mirrored the feature, but because just one feature was selected, the radiuses were not selected. It didn't copy those. So let's see if I can edit this. And for object, one is selected. I'm going to also select that part. So now two are selected. And then now we get it with the curves. If we wanted to put a hole in that, so let's put a hole in there so we can rivet it together. We'll do a sketch. Now, right now, the sketching plane that we've selected is kind of inside there. So it's a little hard to see exactly where we're going to draw our hole. We have a choice here on the sketch menu and the sketch window on the side to slice. If I click slice, it will remove what is between the sketching plane and the viewer. And you can see it's made kind of a cutaway view of where we've cut the part. Right? If I rotate this a little bit, you can kind of see, you know, how it's cut that part. So this allows me to see that flange. Let's make a circle on it, just of, you know, some indiscriminate size. Finish that. We have our sketch, and so now we can do an extrude and choose that. And actually, what I'm going to do, I could either, you know, pull it or type in a value, but just to show you another option, we're going to make it two sides. In each side, we're going to go through everything. So that side through all, and this side through all. And then when I click OK, what it has done is it has made that one sketch through the outer flange, the inner flange, and on both sides. So again, if I go to our flat pattern, we should be able to now see those holes, right? So we got holes here, holes here. We fold this all up together, should be able to rivet it together, bolt it together, whatever we want. So I want to make one more feature on here to make it extra special cool. And then I'll show you how we would actually prepare it for production if we were going to have this made for us. But I was thinking it might be nice to put a few little louvers on the top side. Might look kind of cool. I don't really think it's going to get very warm there, but I thought it might be kind of snazzy to do. And it will let us use, we'll draw that. So the way that I would make a louver is I'm going to first start, let's make a sketch, and we'll cut kind of a rectangular pocket out. And then we'll have an inside edge we can do to make a flange on it. So let's start here by selecting that top surface. Let's make a rectangle. Let's see here. Let's make this 21. Let's make it actually a little bit smaller. Let's make like, well, I'll make this dimension first. We'll make this 130. We'll just center it on here. This can be, again, we can select this dimension and over 2. Make this one, let's make it 19. Oops. There we go. And I think that's I'll scoot it up a little bit like that. We're going to do an extrude to remove that material. Now here's something where, right, if I went too far by dragging it, I could actually cut through, you know, that front panel because it's at an angle. We don't want that. I'll just go through down a little bit. That's good enough. It's a cut. Good to go. Now have our cutout. And now let's create a flange. So the flange is going to be on this top edge here. So I made this cutout 19 millimeters long. Let's make this 18 millimeters for our flange. And for the angle, look at it from the side. But maybe like that, 25 degrees. We can do OK. And so here's another thing where you can also get into trouble, right? So let's go to the flat pattern and make sure that's happy. And it is, right? There's a little bit of a gap all the way around it. If I had made this flange longer, so I'd made it 18 millimeters, let's say I made it 20 millimeters, it would then collide with or hit this other part of the material here, and it would have a failure. Like it'll let me draw it, right? I can, if I edit it, I can make it longer. I can make it like that. Like, oh, well, that's pretty cool. Like it'll let me draw it, but then if I actually want to flatten it, it won't like it, right? It's now drawn something like that. It's like, whoa, that's all one thing there. So that's not going to work. So let's go back and make this. And in fact, sometimes you can get errors. So this was 18. All right. So let's do one more thing here. Let's we'll put some fillets on it. Make the louvers look fancy. Scooch it over a little bit. So we're going to choose this one and this one. And let's make these, I don't know, 15 maybe. And then I think I can actually, in the same feature, can we add a new one? Yes, I think it would make it the same dimension. I'm going to do a new fillet tool, and let's see if I can zoom in and grab these outer edges. Pick that around. There we go. This edge, and I'll make those 16. Recenter it. So there we have a little louver. Make sure it's happy in our flat pattern. It is. There's a little bit of a gap. There's a little bit of a gap all the way around it. Let's do. So we did a mirror for this outer side, that feature on both sides. We're going to use the pattern feature now, and we'll do a rectangular pattern. Again, instead of faces, we're going to choose features. Let's choose our cutout and our flange and our two fillet features. And it's going to ask us for a direction. We can choose like the edge or the face of the plane here. So it's moving on that plane. It's given us 3. Let's start with that. And maybe draw it like that. Okay, and there we go. So now we have our little panel, 3 louvers on the back, mounting tabs to mount it to the dash, and some interior tabs to kind of strengthen it up, strengthen the walls in the back. If I go back to the flat pattern, we now have that. And now we are ready to, almost ready to get it manufactured, to get it cut. The next, so I'll pause here and show you what, so I use SendCutSend for cutting metal, for laser cutting metal. They do a really good job. It's a great site. They have some good resources. If you want to, you can go. They have some guidelines on kind of best practices for laser cutting and for bending and other things. They tell you things like, how they want the files to be created, things to do like how to make different features to keep the cost down, to keep it economical. If you're doing multiple parts, let them lay it out. Anyways, things like that. Check for features that are fully enclosed, not things that have breaks in them or that are open. So once we have our DXF file or Illustrator or whatever we want to upload, we are able to. They are able to cut it for us. So we need to create a DXF file, and the easiest way to create a DXF file is from a sketch. You can export a sketch as a DXF. And you want a sketch that's going to have all of the different lines that you want. So one option would be, we can create a sketch. So we're still in the flat pattern mode. We can still create sketches and cuts in the flat pattern. So let's get ready to create our DXF file for laser cutting. We're going to create a sketch. Sketch is going to be on the top surface of our sheet metal. We have our whole sheet metal here, and the easy way to capture every line is to use the projection. So either the letter P or the under create project, and if you just click on that surface and you click OK, we now have all of the features we've created. Now right now it's still showing that solid model body behind it. If I turn off the body, you see just the sketch, right? So we have just the sketch here of all the stuff that we've done. Now we could, if we finish this sketch, right? So now that's that sketch. If I turn that body on, you see it's kind of overlaid over top of it. And if I expand the sketches, this is the sketch we just created, and it's got the red lock because all of those lines are projections, so they're all fully defined. We can right-click on the sketch and we can do save as a DXF file. We can save it as a DXF. I can put it there. This would be. So if I save that, that's now saved, and we can get that cut out. However, for the lay person like me and probably like you, some of these bends are going to be hard to make unless you have a real press break or some real way to make it or to do an accurate bend. So one of the little features I like to do is I will create a cut, a laser cut in my bend here that does not go all the way through. It doesn't separate the flange from the part, but maybe it goes to about 1/4 of an inch on each side so that I can bend it by hand. I don't need a special tool. Most of the material in the bend is not existent. I can bend it by hand and have a part. So let's go back to our sketch here. If I go back to our sketch, I'm going to show you how what we had projected before was just the flat surface of the body. But in the flat pattern here, we also have the dotted lines for our center lines and then our edge lines where the curves start. So I'm going to project these center lines as well. I'm going to project each of these. Zoom in to grab each one. That one, I've got one here. I've got one here. And the last, oh, there's 2 more. This one and this one. All right, so I've projected those. Turn off that body, you can see it. Right, so now we have those lines projected as well. And but if we had this cut, right, it would cut all these features off, these flanges off. So then I'm going to do another step now where we're going to draw some new lines, and the new lines I'm going to draw are going to be on top of these projected fold lines, but again, leaving a little space at both ends. So I'm just going to draw a bunch of lines. You don't have to be real precise on this. I have found you can kind of eyeball it, leave enough material to keep it connected, but it'll help you make the cut or make the bend.
Would you say roughly half the thickness of your intended material as a rough guide?
For leaving the material on the ends, no, I would probably say like 3 to 4 times the thickness. So if this is 2 millimeter thick sheet metal, probably like 8 to 10 millimeters is probably what I would leave. Probably 8 millimeters. Yeah, about 1/4 of an inch or so is about what I'm looking for.
Okay.
But is the cut all the way through, Van, or is the cut to a partial depth?
No, this cut will be all the way through. So when you laser cut sheet metal, it's going to cut all the way through.
I see.
You would need like a milling machine or a milling process to only do a partial cut.
Right.
So,
right.
So now that I have those lines drawn on top, what I'll go is I'll go back in and I will delete those original projected lines. Now it will, they are now no longer constrained, but I'm not moving anything around, so they can just kind of exist and float out there in space. So I've got a few more to do down here. And one last one here. All right, so now I have those single cut lines in place there. Now if I finish the sketch, it looks like that. I'm going to re-export it. I have to finish, no, I'm in flat pattern here. Go to sketch. Where did my export to DXF go? Am I still in the sketch? Here's my sketch, finish sketch. There we go. So save to DXF. We'll give it the V2 number so you can kind of see the differences. Save. And so now that I have those little lines, I can go to my SendCutSend page again. And I have an account created. I can log in. You can see some of the parts that I've already made, right? Like this is a welding practice piece. This is a die. Actually, I have one here sitting here. Hold it up to the little camera, right? You can see this. Got little cut lines. You can fold it up, make a cube. And then, so this one, if you look, I don't know if the camera can see, you can see those cut lines that are in there. So we are talking about, I would say there's about 1/4 of an inch between that cut line and the edge of the material. And I can bend this and bend it pretty easily and get, that sharp bend there. I'm just going to bend this up like that. Right, and so this is that 2 millimeter, 80 thousandths thickness material. Cut that up. And then the last one, if I want a welding practice, I'd weld along all those edges. There we go. So anyways, once you're at SendCutSend, you can add a drawing. I can grab this dash V2. It will go to load it up, and it's going to calculate like how much area it's going to take for material. It's going to calculate the length of all the cut lines, and will come up with a quote based on that. When you load up your part, you do have a choice between inches and millimeters. Just be aware that if you choose one or the other, right, it was 300 millimeters long, which is 13 inches or 14 inches or so. It's clearly not 357 inches long. So make sure you're in the right units. Otherwise, you might go get your quote and be like, why is this thing so expensive? So I can go choose metals. We'll choose aluminum. When it comes to aluminums, the 5000 series aluminums are the bendable ones. If you're going to be doing sheet metal stuff that you want to bend up, you're going to want a 5000 series aluminum. So you're going to want their 5052. 6061 is more of a machined, is an aluminum that's used a lot for general machining. It's a pretty strong aluminum. It's stronger than the 5000 series aluminum, but it is not as bendable. It will break. It will kind of crack and break at the edges if you try to bend it. This would be something if you were getting it cut out, something cut out like maybe a wheel spacer or something that didn't have any folding or something that needed to be strong. For wheel spacers, though, the 5000 series works pretty well. those alignment stands, I don't know if you saw, I made a set of alignment stands. I had those parts cut out of aluminum by SendCutSend. And the two pieces, there's like little ball bearings, little plastic balls that the slip plate rolls on. I made those out of 6061 because it would be less resistant to getting deformed by the balls, dimpling of the ball bearings. So that would be like an example where I use the 6061. Anyway, so we'll choose the 5000 series, and then you can see that they have different thicknesses. We'll choose the 80 thousandths, the 2 millimeter thick material, and then select the quantity. So if we make just one of them, it's going to be $22.50. If we were to make 1,000 of them, they'd be under $10 each. But we would just want the one. Choose next. They'll deburr it. You add it to your cart. And then, of course, you see that they have a $29 minimum. So they're going to charge you an extra $6.50 because you don't actually meet their minimum cost there. So that's where I would go back and design something else. Like, what else can I make? And that's the genesis of this little welding practice die is, I was creating some parts and they didn't meet the minimum. So I'm like, well, let me think of what else I can make up to at least, it's like free shipping, right? If it's $100 before you get free shipping and you're at $80 and it's going to cost $20 to ship it, you try to find some $20 item that you want so that you at least feel you're getting the free shipping. So, but that's an example of what this would be cost wise, how to make it, and what the cost would turn out to be. SendCutSend is pretty quick. If I ordered it today, I would expect it to be cut out in probably 2 or 3 days, and then they send it FedEx ground, so it'd be a few more days, and then it would be here. So I'd have it like next week. And then I could build it up. In fact, I see, looking at this drawing, that there's one line that I didn't delete. See this one line right here? There's one line between the roof panel and the face panel. We forgot to delete one of those lines, and so this would cut clean through. So I'm glad I spotted that. I'm not going to make this one printed because, again, it's not dimensionally accurate to anything. It was more just an example to show you.
With something like that, would a human being at SendCutSend do any kind of QA and maybe pick up on that and give you a call? Or
they might, yeah, they might. And I have, so actually I will sometimes, when you go to actually check out, you can make a note, and I will say something like the single cut lines are zero kerf. Because really the way the laser cutter, plasma cutter, any type of cutter works, it is using, so laser cutting is using a laser to heat up the metal, and then it's using, for steel it uses oxygen, and for aluminum it uses nitrogen under pressure to blow the molten metal out of the way so that the cut happens because the metal's been removed. So there's a width to that cut, and the machine knows, or they can program in what that width is. So to make this part dimensionally right, that cutter will be offset to the side so that your finished line is in the right place. And these bend lines, they call it a zero kerf cut, meaning that the cutter head will be directly centered over your line. So I'll make a note. And they actually have asked me, they have said, if possible, can you make those in another color or something like that? If you're using, so when I have done that, I would use Illustrator. So if I use Adobe Illustrator, I can open up the DXF file. I just have to tell it the units, right? It's going to be in millimeters, but because it's in millimeters, it's 1:1. So here's the part in Illustrator. And so actually in Illustrator, I can now actually clean it up if I want. Like I could delete that one, or I could make that line a little smaller, or whatever I wanted to do, right? I could, so of course, Illustrator has different, movement and mouse control keys than other ones, but right, I could, put on one side.
got it. Yeah.
And so actually, like their preferred method for, if you do an Illustrator file like this, is to actually use layers. So they would want me to like select these lines. In fact, I might have to make the layer first, but you know, you select your bend lines, you make a new layer, you move these to the arrange to current layer, right? So that now there's you know, there's a layer of the zero kerf cuts, and there's a layer of the you know, offset cuts. And then they say to actually name this layer no kerf or zero kerf. And then, you know, the machine will automatically know. So, but not everyone has Illustrator. You need to have an Adobe subscription and blah, blah, blah. So, you know, I think that if you, you know, you just included a little note that said, you know, the bend cuts or the cuts along the, you know, the single line cuts or zero kerf cuts, there would be an operator that would select those and set those to be zero kerf.